So far, whenever we did input and output with files, it always involved either reading only or writing only. We were never able to combine the two at the same time. So we would open a file, write to it, and then close it. And then as a separate matter, we would open it up and read from it and then close it. In both cases, our access of the data was always sequential. In other words, we opened the file and had to read in order the bytes that were put in there, one at a time, reading them out. Sometimes several at a time because there was some structure involved and some filtering, but nevertheless, we weren't able to jump around within the file and sort of grab something at the end and then go back to the beginning and grab a piece and do that kind of thing. We are now going to investigate something that provides the ability for us to do just that, and this is called random access files. So there's a random access file class that allows us to do this. So in other words, we'll be able to read and write at random locations. So two things are happening now. We're not limited to sequential input and output, and we're also not limited to picking only one of those things, but rather we can move around freely within the file, and we can read from it at any point in time and overwrite parts of it as well anywhere within the file and go back and forth between reading and writing and jumping around from location to location. Clearly, there's a lot more flexibility in what we're about to investigate compared to what we've seen so far. Here is the UML diagram for the random access file class. Most notably, when we open the file, we have to provide a mode because notice the name of the method simply says access. It says random access file. It doesn't say read and it doesn't say write, because we're able to do in fact both at the same time if we want to, and we can specify particular modes to indicate whether we want to read or write or do both. The other thing that's most noteworthy here is the existence of a seek method. If you look down near the bottom, you'll find that, and seek allows us to position ourselves anywhere within the file, including places that we've already visited. So in other words, we could read a half dozen bytes and then seek back to the beginning of the file and start over again, or we could seek right near the end of the file and read some stuff from there. And that ability to seek arbitrarily anywhere within the file is what produces the concept of random access instead of sequential access. The existence of the file pointer then becomes important here because it basically provides that ability to randomly access by indicating whereabouts we are within the file. Ultimately, the file is then just a sequence of bytes. However, when we create it, we've written things to it in a certain order, and that means that if you look at this diagram, where the top of the two diagrams that are at the bottom of the slide, and you see file pointer, that file pointer is pointing to a specific byte, and depending on the context, that could be just a single byte, or it could be a byte in a group of 4 bytes representing a, for example, 32-bit integer, or it could be a byte that is the first of 8 bytes that represents a double. So it really depends what we've written to the file or what we plan on writing to the file, how the file pointer is going to be interpreted. But in any case, strictly speaking, it's just an offset from the beginning of the file. In other words, it tells you what byte you are on within the file. The first byte, the second byte, the 1 millionth byte, wherever you are. And that's this concept of the file pointer. We're free to write whatever we want to such a file whenever we want, and the only constraint is that when we go to read the file back, we have to know what we put in there and we have to know where it's located. Things could get messy, but as long as we keep track of what we're doing, we're allowed to do these kinds of things. The demo that we actually look at is not going to be that terribly sophisticated. It's only going to write one type of primitive to the file, integers only, and in fact 32-bit integers. So because that demo is simplified and only does that one job, then we can make a particular statement about that particular example, and that's that in the context of the example we're going to be looking at, the file consists of quadruples of 4 bytes at a time representing integers, and therefore we ought not to wander off of that sort of 4-byte boundary. In other words, we can set the file pointer to 0 and we know we're looking at the first integer. We should not set it to 1 or 2 or 3 because then we're in the middle of an integer, which doesn't really make sense. But it would be okay to set it to 4 because that's where the second integer begins, and it would be okay to pump it ahead to 8. Now, as long as we're doing readInt, if we're using the readInt method, that's going to grab 4 bytes and bump the file pointer ahead by precisely 4 spots. So as a programmer, we don't need to be worried about that, but we do need to know what we've written to the disk, and if it is all 32-bit integers throughout the file, then that will tell us how we're supposed to treat when we read things out. And as long as we know that that's going on, things will work the way they should. If we've done something very elaborate and clever and done something like, okay, we're going to have an integer followed by a double followed by a byte, and maybe that sequence is going to repeat over and over again. We can do those kinds of things, but as I said, you have to be very careful to keep things organized so that the file pointer is always pointing to the correct spots where things actually exist. And then as long as you're using the appropriate readInt, readdouble methods to pull those things out, things will work the way they're supposed to work. We're going to purposely blunder up the demo. We're going to read from a place we shouldn't to show you what happens, because I think it's important that you understand that. Our demo is essentially going to write a bunch of 4-byte integers to the file, and we're going to access it in a random way, and we're going to read and write to illustrate that we can do both at the same time. And after we finish that demo, but before we finish the entire lecture, we're going to then fool around a little bit and advance that pointer to a place where it ought not to ever get, and show you what happens if we do that. And I think that will really help you understand some of the intricacies about what's going on here. So a lot of the things we've already become familiar with in terms of reading and writing primitives to and from a file are still going to work in the context of random access files. The seek method will allow us to position the file pointer anywhere within the file to any arbitrary location. The only constraint, of course, is it doesn't make sense to seek past the end of the file. If you do that, that will throw an IO exception. The file pointer is actually a long integer, so it can accommodate extremely large files. And if you want to know its value, you can use the getFilePointer method to find its current offset. And that's always measured in bytes regardless of what's in the file. So it doesn't matter if you've written doubles or integers or something else to a file, the file pointer is always measured in bytes from the beginning of the file to the next place that a read or write is going to occur. There's a length method that tells you how big the file is, and you ought not to let the file pointer get beyond that. The only exception is when the file pointer is at the end of the file and you write something new out to the disk and make the file larger. And if you've done that, of course, requerying the length method is going to return a larger value once you've done that. The write_char method will write out a 2-byte Unicode value, and the write_chars method with S on the end of it will write out the file as a sequence of characters. Because we now have the ability to not just read or just write, but we can mix together reading and writing, there has to be file modes that allow that to happen. So you recall our introduction of creating a random access file and looking at the constructors that exist for it. One of the arguments that it accepted was a file mode. So the first argument is a file name, the next argument is a file mode. And if you use, it's a quoted literal string with double quotes around. If you use RW, that means read and write. So you're opening the file for both reading and writing. If you have just an R, then it becomes a read-only file.